Hello everyone. Today I will be explaining about the physical phenomenon of gravity. First, let's start off with something very simple. What is gravity? Gravity is the force of attraction between two objects. Okay? Any object with a higher amount of mass will be able to have a higher amount of gravitational pull on an object with a lower amount of mass. So let's draw a little example here. Let's say that this is the sun and this is the earth, this is the moon. Okay, so this is the center of the earth, this, let's say, it's the center of the moon. The moon will always be in orbit around earth because there's a sense of gravitational attraction between these two bodies. The moon exerts some amount of gravitational force on the earth, but the earth exerts much more on the moon, which makes it locked. And now let's look at the sun. This is our sun center, and this is the earth center. The earth is gravitationally attracted to the sun, so it'll always move in an orbit like this with the sun. But how does this actually work? So Einstein said in his theory of relativity that the universe is not just a flat square like this. If we place a sun or a star on it, the space will actually curve underneath. So in this curved space, let's say that this is our sun, this is the earth. Just redraw that a little bit. This will be our curved space. This is our sun, this is the earth. Because this is curved, the earth will slowly fall down and make a circular orbit around the sun, but never being able to touch it, because it's sort of like if we have a drain and we drop a ball into it. The ball can constantly circle the drain, but it will only be able to touch it when it's lost all momentum. Since the earth can never lose its momentum, it will always remain fixed in an orbit around the sun, like this. And here there are two things that you have to differentiate: the gravitational constant and the force of gravity. The force of gravity is this thing right here that's attracting these two, but the gravitational constant will be the mass if we were on a specific object. So if we have a human on the sun, they would burn. But more importantly, for this example, their mass would be the same, but their weight would be much more due to the strong gravity on the sun as compared to the earth. And if they were on the moon, they would be even lighter. So as our gravitational force constant decreases, their weight decreases. But gravitational force is not a constant. So the equation to find that is gravitational force is equal to the gravitational constant multiplied by the mass of the first object plus the mass of the second object divided by the distance between the two objects squared. So let's say that we have a person weighing 60 kilograms on Earth. Okay, let's assume that the mass of the Earth is approximately 1 million kilograms for this example. It might not be the exact measure, but this is what we will be using. They are approximately 20 kilometers from the core. So what we would do here is say that the gravitational force is equal to 9.8, which is the gravitational constant on Earth, into 60 plus 1 million over 20 squared. That means we would get Fg as 9.8 into 1,060 over 400. Now here what we'll do is we'll just cancel the zeros and divide by 100. So if here is the decimal point, we'll just move it to 1, 2. So we should get 10,000.6, so Fg is equal to 9.8 into 10,000.6 over 4. And now if you wanted to find the actual value, you'd obviously just take this and plug it into a calculator. But in some questions, this format can also be acceptable. Okay? That is basically our formula for the gravitational force. If we wanted to find the constant, however, all we would have to do is start to reverse the equation. So we would say that Fgr squared is equal to g plus m1 plus m2. And say the g m1 plus m2. So we'll get Fgr squared over m1 plus m2 is equal to g. So anyway, that was everything about gravity. Hope you enjoyed this video, and I will see you in the next one. Bye.